To determine the correct section of the National Electrical Code, or NEC, for an optional method of calculating feeder and service size for a retail application, refer to Article 430, which covers motors, motor circuits, and controllers. Specifically, Section 430.26 Code provides an optional method for calculating the feeder and service size for retail occupancies where the actual load is expected to be less than the calculated demand load. This method is not applicable to commercial occupancies. The formula to use is feeder or service ampacity equals demand load multiplied by diversity factor. The demand load is calculated using Table 220.43b, which covers lighting load, and Table 220.43c, which covers appliance load. The diversity factor for retail occupancies with floor area up to 10,000 square feet is 0.75. The diversity factor for retail occupancies with floor area over 10,000 square feet is 0.80. For example, imagine a furniture store in Kansas City, Missouri has a floor area of 15,000 square feet and track lighting is used, with 150 volt amps per 2 feet. The total length of track lighting is 10,000 feet. Firstly, calculate the lighting load, which is 150 volt amps per foot multiplied by 10,000 feet, equaling 1,500,000 volt amps. Secondly, determine the demand load from Table 220.43b. The calculation is 1,500,000 volt amps multiplied by 0.6, equaling 900,000 volt amps. Thirdly, the diversity factor for a floor area over 10,000 square feet is 0.80. Finally, calculate the feeder or service ampacity, which is 900,000 volt amps multiplied by 0.80, equaling 720,000 volt amps. Therefore, a feeder or service with an ampacity of 600 amps would be needed, as this is the closest standard ampacity to 720,000 volt amps. Using this method allows for a more accurate estimation of the required feeder and service size based on the specific characteristics of the retail occupancy. For calculating the demand load for the feeder or service, it's important to correctly apply the demand factors listed in Article 220. These demand factors allow for the reduction of the total calculated load based on the likelihood of all connected loads operating simultaneously at their maximum rating. Specifically, Table 220.43 provides demand factors for various types of occupancies and loads, including lighting, receptacles, and appliances in retail establishments. When applying these demand factors, ensure that the calculations accurately reflect the expected usage patterns of the retail space. This may involve considering factors such as the type of merchandise being sold, the typical areas of operation, and the presence of energy-efficient technologies. The correct application of demand factors can significantly reduce the required feeder or service size, leading to cost savings without compromising the electrical system's capacity to handle the actual load. In addition to lighting and appliances, consider other significant loads within the retail space such as HVAC systems, refrigeration units, and any specialized equipment used in a business. Each of these loads should be calculated based on their nameplate ratings and any applicable demand factors. It is also important to account for any future expansion or changes in a retail space that may impact the electrical load. Planning for future needs can help avoid costly upgrades or modifications to the electrical system down the line. The diversity factor is applied to the overall demand load to account for the fact that not all electrical equipment will be operating at its maximum capacity at the same time. The diversity factor is typically less than 1, and it reduces the overall calculated load, resulting in a smaller required feeder or service size. In the context of retail occupancies, diversity factors are based on the size of the floor area, with larger spaces generally having higher diversity factors. This reflects the idea that larger retail spaces tend to have a more diverse mix of electrical loads, and the likelihood of all loads operating simultaneously at their maximum capacity is lower. When using the optional calculation method in Section 430.26 Code, it is crucial to maintain detailed records of all calculations and assumptions made. This documentation should include a list of all connected loads, their nameplate ratings, applicable demand factors, and the resulting calculated demand load. The documentation should also include the diversity factor used in the final calculated feeder or service ampacity. These records are essential for demonstrating compliance with the NEC and can be helpful in the event of an inspection or future modifications to the electrical system. It's also important to ensure that the calculated feeder or service size is adequate to handle the actual load of the retail occupancy. This may involve conducting load monitoring or measurements to verify the accuracy of the calculations and identify any unexpected loads. If the actual load exceeds the calculated capacity, adjustments may be necessary to ensure the electrical system can safely and reliably handle the load. One must consider the impact of energy-efficient technologies on the electrical load of a retail occupancy. Energy-efficient lighting, appliances, and HVAC systems can significantly reduce the overall electrical demand, potentially allowing for a smaller feeder or service size. When using energy-efficient equipment, it is important to accurately account for the reduced load in the calculations. This may involve using manufacturer's data or conducting measurements to determine the actual power consumption of the equipment. The use of energy-efficient technologies can not only reduce the required feeder or service size but also lower operating costs and improve the sustainability of the retail establishment. When calculating the feeder or service size for a retail occupancy, it's important to account for any voltage drop in the electrical system. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source due to the impedance of the conductors. Excessive voltage drop can cause equipment to operate inefficiently or even fail, and it can also violate the requirements of the NEC. To minimize voltage drop, it may be necessary to increase the size of the conductors or reduce the length of the circuits. The NEC provides guidelines for calculating voltage drop and specifies the maximum allowable voltage drop for various types of circuits. The calculation method described in section 430.26 CON is an optional method, and it is not always the most appropriate choice for every retail occupancy. In some cases, the standard calculation method in Article 220 may be more suitable. The choice of calculation method depends on the specific characteristics of the retail space, the expected load patterns, and the level of detail available in the load data. It is important to carefully consider the advantages and disadvantages of each method before making a decision. Consulting with a qualified electrical engineer or inspector can help ensure that the most appropriate calculation method is used. Always remember that electrical codes and standards are subject to change, and it is important to stay up to date with the latest requirements. The NEC is typically updated every 3 years, and it is essential to use the most current version of the code when designing and installing electrical systems. In addition, local jurisdictions may have their own amendments or interpretations of the NEC, and it is important to comply with these local requirements. Staying informed about the latest changes and requirements can help ensure that electrical systems are safe, compliant, and efficient. The installation should adhere to the guidelines provided in the NEC, including proper wiring methods, overcurrent protection, and grounding. These measures are essential for ensuring the safety of the electrical system and protecting against electrical hazards. The NEC specifies the requirements for various aspects of electrical installations, such as conductor sizing, conduit fill, and equipment spacing. It is important to carefully follow these requirements to ensure that the electrical system is installed correctly and safely. The grounding system is a critical component of an electrical installation, as it provides a path for fault current to flow back to the source, allowing overcurrent protected devices to operate and clear the fault. The NEC specifies the requirements for grounding electrodes, grounding conductors, and bonding of metallic equipment. A properly designed and installed grounding system can significantly reduce the risk of electrical shock and fire. Overcurrent protection is another essential safety feature of an electrical system. Overcurrent protective devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. This protects the electrical system from damage and reduces the risk of fire. The NEC specifies the requirements for overcurrent protection, including the selection and sizing of overcurrent protective devices. Proper overcurrent protection is essential for ensuring the safety and reliability of the electrical system. Furthermore, The proper selection and installation of electrical equipment is crucial for ensuring the safety and performance of the electrical system. Electrical equipment should be listed or labeled by a recognized testing laboratory such as Underwriters Laboratories or ALL to ensure that it meets safety standards. The equipment should also be installed in accordance with the manufacturer's instructions and the requirements of the NEC. Improperly selected or installed equipment can pose a safety hazard and may not perform as intended. Regularly inspect and maintain the electrical system to identify and address any potential problems before they become serious. This includes inspecting wiring, connections, and equipment for signs of damage, wear, or corrosion. It also includes testing of current protective devices to ensure that they are functioning properly. Regular maintenance can help extend the life of the electrical system and prevent costly repairs. Furthermore, it is important to consider the environmental conditions in which the electrical system is installed. In damp or corrosive environments, it may be necessary to use special types of equipment and wiring to protect against damage. The NEC provides guidance on selecting equipment and wiring for various environmental conditions. Taking into account the environmental conditions can help ensure that the electrical system is reliable and long-lasting. In addition to the technical aspects of electrical calculations, it is important to consider the economic implications of different design choices. A larger feeder or service size may provide greater capacity for future expansion, but it also comes with a higher initial cost. A smaller feeder or service size may reduce initial costs but could limit future expansion options. It is important to carefully weigh the costs and benefits of different design choices to arrive at the most cost-effective solution. Remember to consult with a qualified electrical contractor or engineer to ensure that the electrical system is designed and installed in accordance with all applicable codes and standards. A qualified professional can provide valuable expertise and guidance throughout the project. Hiring a qualified professional can help ensure that the electrical system is safe, reliable, and compliant. Moreover, familiarize yourself with the relevant sections of the NEC and other applicable codes and standards. This knowledge can help you better understand the electrical system and make informed decisions about its design, installation, and maintenance. Staying informed about electrical codes and standards is essential for ensuring the safety and performance of the electrical system. If one is unsure about any aspect of electrical calculations or installations, it is always best to seek professional assistance. Working with electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from harm. Seeking professional assistance can help ensure that electrical work is performed safely and correctly. Finally, always prioritize safety when working with electricity. Follow all safety precautions and use appropriate personal protective equipment. If you are not comfortable working with electricity, do not attempt to do so. Leave the work to a qualified professional. Prioritizing safety can help prevent electrical accidents and injuries.